Now we will see how the soil moisture sensor will work. This is that soil moisture sensor. I will show you. Yeah, this is that soil moisture sensor. You can see this. It is available for around 40 to 50 rupees in the websites. You can buy it. It's a soil moisture sensor. Now here, uh, okay, I will explain you. Here you have four pins. Look at this carefully. 1, 2, 3, 4. Okay, one side you have four pins, another side you have two pins. Okay, this is the main circuit. Another side you have two pins, and this is the that two conductors. It has a two conductors. Okay, this one legs and this one legs. From that, two wires are there. So you need to connect these two to the here one symbol is there. In this side you need to connect this. There is no any plus or minus. You have to connect simply like this. Okay, then in this side here it is written that this is VCC, and I will show that. Okay, will show with this pointer. This is a VCC. Here you can see it is written as VCC, and here this is a ground. Second pin is the ground, and this one is the D. They are writing at D0. That means this is the digital pin, digital output, and this is the A0, means analog output. AO, analog output, digital output, ground, and VCC. It has a four pins. Okay, see this. I think it's visible. Yeah. Then now what we will do means we will connect four wires for it. So I have a four wires here. That is a male to female wire. Here I will connect it. For VCC I am using this red color. This is my VCC. Okay. Then this is the ground. Ground we are actually prefer white or black color. Okay, this is my ground, and this is the what is this digital output. That means it will produce the output either 1 or 0. Okay, 1 or 0, and this is the analog output. That means it will produce the range between 0 to 1023. Okay, so now this is our measuring. That means we need to put this in the soil, and here we have, yeah, VCC. I am connecting to the VCC. Here you can see here plus 5 volt or V in, both are same. Okay, you can give on to the V in or plus 5 volt. This time I will give for V in, or you can give it to the plus 5 volt. Okay, plus 5 volt, and this is for the ground. When you connect those things, if it is proper, it will produce the light. In some modules the light may not be there. Okay, then here is one resistance setting knob. No need to worry about this. This I will tell what it will later. Now what we have to do means, here this is the digital output. So I will connect that digital output to any one of these pins. Okay, digital output. This, okay, I will connect this to the pin number 8. Okay, then here is the my analog output pin. This I will connect it to the analog A5. Okay, A5 I will connect. Remember, digital we connected to pin 8 and analog we connected to A5. Now when you come to the code, I will open the Arduino IDE, and when you come to the code, first of all we need to write setup. We need to set up the analog pin as the input, A5 as input, as well as this 8 digital pin 8 as input, because we are reading some data from this sensor. Okay, that is soil moisture sensor. So from here what I will do means, pin mode, okay, pin mode 8 comma input. Okay, this is my digital input pin. Okay, similarly what I will do means, pin mode A5 comma input. These two I will declare as the input. Okay, these are the input pins. Then what else is required? We need to display these results in the serial monitor, because we have to verify whether the sensor is working or not. So here what I will do means, serial dot begin 9600. Okay, it will start the serial communication with the computer serial monitor. Then here what I will do means uh, I will assign some variables. I will assign two variables, int a comma b. Okay, I will assign two variables. Then a equal to digital GITAL read. Here we are reading, we are not writing to the sensor. We are reading some digital input data, that means 0 or 1 from this sensor. Okay, that means when the sensor is with full of water, when it is with full of water, it will give the output as 1, and if it is no water is not there, then it will give the output as 0. Let's see that whether it's right or wrong. A equal to digital read. What pin I am reading? I am reading the pin number 8. Okay, then B equal to digital read means it will read whether 1 or 0. Okay, then B equal to analog read. That means this function will read the values from 0 to 1023. That means it will give the range, how much wet is there, whether it is more wet or less wet or more dry, that those things. Okay, analog read which pin? A5 I will analog read. Okay, then we will convert this to some, this is now in a 1023 range, we will convert that to plus 5 volt. So B equal to, I will use the same variable, in that only I will convert. B equal to, what I have to do? B divided by 1023. For 1023 it is the analog read of A5, that means B value like 1000 or 900 something. Then for what is for 5? What is for 5 volt? Okay, this I will put in bracket. No need of putting a bracket here, but simply okay. Then I will display these two things. Serial dot print. Serial dot print. What I will do means STURE moisture content in soil is. Okay, this type I will write one sentence and I will display the serial dot print serial dot print ln, no, serial dot print, okay, print ln. I will use serial dot print ln, and here digital value, that means it will give you the output of 0 or 1, digital value. Okay, what is the digital value? Serial dot print, my digital value is A. Okay, A. In the same way, analog value we need to display. So I will display here analog value, here I will display B. Okay, after serial dot print digital value, yeah, here I think it will print this moisture content in soil is. After that we want one line, so serial dot println digital value, here no println. After this we want println because it has to jump to the next line. Analog value, yeah, here also it is not required, serial dot print analog value println. Okay, analog value. After this, if you want one blank line, just serial dot println, just close like this, and here for every second I want delay 1000. Okay, now let's see whether this code is proper or not. I will save this. We'll check whether it's proper or any error is there. Yeah, it's done compiling, it's proper. Now we will upload the code and we will see here. Yeah, it's uploading. Yeah, it's uploaded. You can see this. Now when we open the serial monitor, you can see the digital value is 1, analog value, yeah, will it is something wet, just now I put it in water. Analog value 5 means it is 1, digital value, and analog value it's matching. We'll make this, yeah, you can see it is a it's giving 5. Now for example, if we have the water, look at the digital value, now it is 1, it will change to 0. See, 0 0 0, both are 0, properly it's 0. Okay, see, that means it's detected. If I remove from this, it will change. We will see this in a 1023 range, then that's better. You will come to know. If you convert to 5 volt, again we need to convert. Why we need to convert this to 5 volt? Because we are reading analog, we have to know what is there, how much content of soil is wet properly. So yeah, see, now it is giving in the range of 1023. That means there is no moisture. If it is 1, there is no moisture, so moisture content is more, it means moist. So we just change it. Here instead of moisture content we use dryness, DRYNESS. Dryness content is in the soil, how much dry it is there. Now we will upload it. Yeah, dryness content in the soil is full. Now it is 1 means it is full dry, because I am not dipping in this water. If little bit water is there, then you see I will go on putting this, just little bit I will put. You see that analog value it decreases to 520, 541. See, if I put full, then it will decreases to, yeah, 270, 283, like that. Digital value, you see it's a perfect one, 0. If I take from this, it will give 1. That analog also 1020, 1023 it is giving. If I put in the water little bit, it will give 448, 463, 532, 578. You can see 713, 8930. Yeah, that means if we put this in a soil, actually you have to put this in a soil. Yeah, sorry if you're not seeing this, I will show. See, yeah, actually if you put this in a soil it will give the proper result, but here I am putting directly in the water. Here you can see if a little bit of moisture is there, then it will give the analog value as 949. That means little bit less it will give. If more moisture is there, then the dryness content in soil, dryness is 0, because it is completely of water. Like that we need to analyze it. Okay, that means if it is not conducting, it will give the output as the high output. Okay, if it is not conducting, if it start conduct, if it is fully conducting, then it will give the output as 0. If it is not conducting, it will give the output as high. Okay, this is what the soil sensor, soil moisture sensor. You can ask why we have to use this soil moisture sensor. We can directly dip this analog input and plus VCC to the water. No, we will try that. This is our analog input pin. Okay, and this is my plus VCC. Okay, I don't need this digital pin now. Now we will directly dip this in water and we will see whether we will get the output or not. You see analog value 995. When I dip full also it is 942. Yeah, sometimes it will give. That means its conductivity is very less. It will recognize, but if we dip directly, take 2 wires, and if we dip directly, it will recognize, but it is not more efficient. That's why we are using something called this soil moisture sensor. But nowadays these sensors are also, they will not use, they will use some capacitance based soil moisture sensor, so that it's more accurate, and it will not corrode easily. Now it will get corrode sometimes, corrosion. In this way you can measure. Now we will make one small project, okay? That is, when the soil content is too dry, it has to alert us. uh, yeah, instead of that, what we'll make, no, we'll make tank one. Tank, if tank is full, then it has to give the buzzer. Okay, for that, what I will do means, I will use this moisture sensor for that use. But it is not too preferable. If you use this moisture sensor for tank, it is not good, because we can make it easily. Okay, uh, think more practically what we can do. uh, we'll make like, if the tank is full, then the pump set has to off. If the tank is less, then the pump set has to on. Like that, uh, think about it, and if possible you make that. Now I will show what you have to do means, I will just on the buzzer, because we learned the buzzer in the previous things. I will on the buzzer if the soil is too dry, and alert the people that the soil is too dry, please put some water for it. Okay, for that, the connection is same. We can use the this analog pins. Okay, here VCC and ground, and this analog pin I will use. Digital pin I will not use now. Okay, then these two are the, this is for VCC, VCC. This I will remove. This is for VCC, or V in we can use, and this is for the ground. Ground I will connect, it will give the light. Okay, now can say this I remove. Okay, you see these three things, and have a buzzer here. Okay, this is my buzzer. Okay, this is my buzzer. Now what I will do means, I will connect this buzzer to some pin number 13. Okay, pin number 13, I will connect this buzzer. Pin number 13, I am connecting this buzzer, and another end to the ground. Here is a ground, so I will connect this to the ground. Okay, now what I will do means, the buzzer I connected, see, buzzer I connected. Now in the code, what I will do means, if the dryness content in the soil, if dryness is more, then it will give 1. Okay, 1 as the output. Okay, or here digital, no, we are taking the analog value, so if dryness is more, it will give 1024. We will see, if it is, the dryness is more than 900, then it has to give the buzzer. That means here what I will do means, if my analog read value is the B value, if B is greater than or equal to 900, then tone, which pin we are connecting, 13 comma some frequency, for example 1200. Okay, 1200, then yeah, 1200, then delay 500. That means no, 5000. 5 seconds, no, 3 seconds is enough. 3 seconds, it will, two statements are there, so put brackets. If it is more dry, then it will alert for 3 seconds by making the sound in the buzzer. Okay, every second it will check for the moisture, and here we need to declare that pin. So pin mode 13 comma output, 13 comma output. Okay, yeah, now we will see whether our code is proper or not. I will upload the code. Now it is more dry because it is completely open. Yeah, now you can see it is alerting for 5 seconds because it's completely open. Okay, so now what I will do means I will dip this in the soil moisture sensor, this water. We will see this, and log value is 308. Then why it is giving? Because we forgot to, I will remove for a time being, because if it is not, if it is less than 500, we need to stop this tone. That means after the 3 second we need to stop the tone. We not tell the Arduino in the program that you need to stop the tone. It delay for 3000 second, then it continue because there is no any no tone function. So here what I will do means no tone 13, no tone 13. So after 3 second it will stop the tone. Now I will upload, and this I will put in the water, and this I will connect to the, yeah, so I will connect it. Now you see in the serial monitor, okay, here it is 324. That means the it is more of moisture. If I remove this, yeah, you can see it will buzzer for 3 seconds and it will silent, and again it will 3 seconds. Yeah, if I put in the water, that means if the moisture soil contains more content of moisture, it will not alert. Like this you can help the farmers. See, yeah, it's working. So think about application of this. I think you hope understand this. Can see the connections here. Yeah, thank you.